Welcome to the Lord Kelvin Lecture. A little bit of background on the Lord Kelvin Lectures. Many of you will have heard of Lord Kelvin. Many of you will have heard of the Kelvin scale. Lord Kelvin was an early president of the Institute. And he was one of the first presidents, in fact, not the first, but one of the first. And we established the lectures in his memory to reflect upon his achievements, and in particular his visions. He achieved worldwide fame not just for establishment of the Kelvin scale, which was named after him. He achieved fame both in the sphere of pure science, physics in particular, but also in the application of his knowledge of physics to practical use. Among his numerous inventions, those by which he's chiefly remembered in the maritime community are, of course, his patented ship's compass and sea sounding apparatus, which were universally adopted. The lectures are given by distinguished members of the maritime community, taking Lord Kelvin's foresight and applying it to the development of future technologies. And tonight's lecture, which is titled Rolls-Royce's Vision of Autonomous Shipping, is going to be delivered by Kevin Daffey. We're very pleased to welcome Kevin. Kevin is a chartered engineer and fellow of the IMarEST. He's one of ours. He's obviously with Rolls-Royce. He's Rolls-Royce's Director of Engineering and Technology, Marine. He's been with Rolls-Royce since 2003. He's held a number of positions, but in February 2016 he became Director of Engineering and Technology for the £1 billion marine business. He's leading 1,300 engineers in technology function, in the development of new and innovative technologies, in nurturing the engineering capability within Rolls-Royce. Of course, that helps nurture the engineering capability in the wider sector. And he's also responsible for the governance of product safety, which will be quite interesting. So that's more than enough from me. Let me get Kevin up and let him make a start on the presentation. Thank you.
Thank you, Paul. Well, good evening, everybody. It's a real great pleasure to be invited to give the Lord Kelvin Lecture this evening. I'm going to talk to you about the vision that we have for remote and autonomous vessels. None of this is my work. This is all a team of people that work for me and some of the great work they've done. But as we go through this, it's going to generate some questions and thoughts, and hopefully tonight we can have a good discussion about them. I think the first thing that we ought to do is we ought to start with the vision. So let me show you this video.
We live in an ever-changing world where unmanned and remote-controlled vessels are becoming reality. Let us share a view of this world with you. The control room is the nerve center of remote operations in the Rolls-Royce OX concept, where the global wall shows a real-time overview of worldwide shipping traffic. A full situation overview is presented to operators who are monitoring vessels via remote link from their onshore workstations.
Dynamic Positioning Reports DGPS-1. Lost connection for vessel RR9835. Suggested course of action. Diagnostics. Commands?
Proceed.
GPS, geopositioning and celestial navigation status. Nominal. INS status. Transmission stopped. Suggested failure mode, physical. Commands?
Stand by. I'll have a closer look.
Drones 01 through 08 ready for inspection flight. Commands?
Launch drones 1 and 2. Flight plan. Standard inspection routine. Camera control. Manual with eye track. Deploy replacement for selected antenna. Schedule post-mortem inspection and change of antenna at next port of stop. Add checkpoint for operator at selected time. Verify navigation data integrity.
The vessel is ready for handover to local operator at West Coast VTS. Transferring administrative documents. Suggested course of action, break and refreshment.
Okay. Leave the documents open when they're ready.
Confirmed.
The OX local wall presents a place where vessels and traffic in the local zone are tracked and controlled, and their port operations are scheduled, controlled, and managed.
Vessel RR9835, pending transfer to local VTS. Administrative documents ready for review and approval.
Okay, preview on tablet. List a summary of tagged events for the new vessel on wall.
Vessel RR9876 reports repeated eco-efficiency fluctuation above preset threshold.
Page experts to local workstation 6.
In OX, situation handling is made efficient with sharing of information and flexible use of data. System specialists are available on demand for problem analysis and assistance.
Welcome.
Show me a summary of propulsion motor operation for the past 3 hours. Play audio.
Vessel tagged with situation handling for all operators.
Right, bring vessel biz to collaboration table 1.
The OX collaboration table is a tool dedicated to teamwork and in-depth situation analyses and reviews, allowing ad hoc problem solving on a shared and flexible presentation platform.
We are looking at a vessel with possible propulsion motor failure. We need to decide whether she can sail to port with both motors, or if she needs to shut down the other shaft line. Judging by the motor sound, I'm suspecting a failed feedback sensor. We could bypass it by changing to model-based open-loop feedback, and I'm positive that she can then sail to port with both shaft lines operational. But I wanted to hear your opinions.
With unprecedented flexibility of use, operational efficiency, and resilience against the unexpected, Rolls-Royce OX concept brings you the next generation in marine operations. Rolls-Royce, trusted to deliver excellence.
So I think it was important to give you sort of a view of the future, just to set a scene in terms of what it could be. And actually, a lot of the technology that you saw there, I've actually got in development now. You know, it won't be reality next year, but in the next couple of years, a lot of that technology will be available to people. And one of the reasons that we did that video, you can actually look at that video on YouTube. It's had over 250,000 hits. It was actually shown at the IMO MSC 98 as well. And the idea is that it was to really sort of set that vision for the future, not only for the industry, but actually internally for us, because, you know, when we started this journey, some people thought, one or two people who started talking about it were actually mad. You know, how can you actually posture a business to deliver that sort of technology? And it's really good to set that sort of vision for your team if they're going to develop exciting technology. The other thing that it's done is it's helped us bring people into the industry. I set up an R&D centre in Turku last year in Finland, and we advertised for a couple of dozen jobs, and we had over 1,000 applications to come and work for us in our area. And we often complain in marine that we don't get enough people coming into our industry to help us, but actually if you set an exciting vision, then people will actually come and want to work in your industry. So we are coming to an area in marine where we are going to get disruption. It is going to change, and we can either embrace it and take it as opportunity, or we can resist it and we can fight it all the way along. And actually this type of technology is one of those which is actually, when you go around and you do these presentations and debate, you always get a number of people who are quite sceptical about it, and they say it's not coming, people are not demanding it. But actually we're finding a lot of customers are talking to us, and I'll go through some of that later on today. But the disruption's coming around the rest of the world, and it's really being enabled by data and digital. Data is becoming a new currency. People are beginning to realise that they can actually take data from operations, whether it be in a factory, whether it be from the sea, and they can turn it into insights, and using those insights they can create new business models. And we've seen a number of people in play at the moment. You know, you only have to take Uber here in London, in other cities. You know, they've just completely disrupted the taxi market. People are resisting it, it's causing issues, but still it's transformational. Tesla again have come in. They're not a car manufacturer, you know, they weren't a few years ago, but now they are, and they're taking on the big giants, the GMs, the Fords, with their technology. Amazon have completely revolutionised how we shop. How many of us here tonight will be shopping online and getting most of our Christmas presents online through Amazon? Hands up, I'm guilty. And Spotify, you know, I spent all afternoon listening to Spotify on the train coming here. I find it brilliant. It's great. You know, any song that I want, I can get it on Spotify. If I hear something, I get Shazam and I listen to it. I get it on Shazam and then I put it to my playlist. What a great way of, you know, discovering new music and new art. Fantastic. So all of these things are coming in. In industry, you know, we've got big data, we've got Industry 4.0, which is connecting lots of equipment with sensors. You know, and it's completely transforming the way that manufacturing and supply chains work in the whole industry. And it's coming to shipping as well. You know, shipping is just part of a value stream. You know, it's just part of an integrated operation. It's either transporting goods, but it's only part of it. You know, the goods are then going to go by road, they're going to go into shops, they're going to go into manufacturing places of work, as it were. We take raw materials, and we just transport it, we ship it. We ship people around the world as well, and we take money off them. You know, that's just the value chain. That's just what happens. And it's becoming more prevalent that, you know, some of these companies like, you know, your Amazon and Alibaba are going to actually break into our industry, and they're going to transform things. They're going to change the way that we do shipping. A lot of the middlemen probably are going to find it quite difficult in the next 5 to 10 years to actually make money. They'll be displaced, they'll be disintermediated. And it's all being driven by digitisation. And there are 4 areas that I see are changing. So first of all, on the operational side, there are some new technologies coming in, which we'll talk about. So, you know, we've got health management and we've got digital management. So the health management of equipment, asset management of ships, and remote operations. Lots and lots of people now are actually monitoring their fleets from remote centres, gaining insights and giving operational decisions back to the vessels. Then you've got a number of different technologies which are coming through, and we'll talk about some of these later. Situational awareness, remote control, Just even being connected and remote commissioning and remote assistance can also be sought on vessels. And then we've got, you know, the management we just talked about. You know, you can now start to do data analytics on a lot of this big data. You know, we can transform and we can look at many gigabytes of data. Just within Rolls-Royce, we manage 2,400 terabytes of data in our business every year, and every other business is managing huge volumes of data. And supply chains are becoming more integrated with Industry 4.0. You know, you can actually make a call for parts, and that can go into an electronic marketplace. It can find machines in different suppliers, and it can get those machines to actually download all the CAD files and start the machining straight away. This is coming in automotive, it's there in aerospace, and it's coming in the marine industry. And then we've got different business models which are coming along as well. So people are talking about, you know, smart shipping. We can expect digital startups coming in. I mean, only a year ago, Alibaba and Maersk started working together on part shipping goods through containers. You know, just finding spare spaces on containers. You know, so these are the new business models which are coming along. And more, we're finding that ships and shore are becoming more integrated together. That means that you know, the lines between what is done on a ship and what's done ashore are getting more and more blurred. And communications is the key enabler here. You know, tasks that are done on ships today can be done ashore and vice versa. And just to give you some examples of those, it's pretty common now to get remote assistance. Now, you know, we have DP systems installed in platform support vessels and subsea vessels all around the world. And quite often, you know, the ship will contact us and say, we have a particular problem, can you help us? And we'll get an engineer in Norway who will dial in, and he'll be able to then diagnose what the problem is. Saves us having to transport somebody out there in the ship coming off of hire. You know, this is becoming more and more prevalent. We're now doing remote commissioning now, so some of our best engineers don't actually have to go to the shipyard in Manitoba or go to the shipyard in Gdansk or out in China. They can actually do a lot of the work remotely, and we can dispatch fewer people and save costs and time for the shipbuilder. So remote assistance is something that's becoming pretty standard in our industry. And we're also moving away from time-based maintenance. We're getting into condition-based maintenance and what we call dynamic maintenance planning. So now we can get enough information back from our equipment, and we can say, okay, at the next docking, all we need to do is we need to change one cylinder on the engine. We need to change a liner there and the oil pump. We don't need to do a complete overhaul because we know the condition, we're confident of the predictability of the failure within the equipment. This is something that the aerospace industry and airlines have been using a lot, and it's saved millions and millions of dollars in maintenance, and this is coming now to the marine industry. And a lot of the big operators of vessels now have their own operation centres, and they're doing decision support on land based upon lots of information they get through, the insights they're getting from the operation of the ships, maybe the prices of oil around the world, and they're guiding them, the ships, to do what they need to do and bringing that decision making on shore. Then we get into remote and autonomous shipping. And before I get into this in more detail, it's probably worth exploring why we want to do remote and autonomous shipping, because it's not always obvious why we want to do it. So first of all, let's just start with the degree in which we do autonomy. So in the automotive industry, they used a particular sort of framework where they graded things from 1 to 5. We've used something from 0 to 4. So 0 means that there is no automation on board. Everything is done by the crew on board, all the way through to level 4, which is where there are no people on board, and all of the decisions and all of the safety is done by the machines, as it were. And then you've got a continuum in between. And you start on a journey that probably starts at 0. You know, if you look at tugboat operations, it's a pretty manual set of operations. There's very little automation on tugboats. But then you get into level 1, where you get this partial autonomy. So, you know, you target certain operational tasks, you know, sequences of starting engines and shutting engines down. The sequences is done by the machinery and the automation system. But the crew at all times, they decide when you start and stop, and they oversee the process, and it will drop back to manual mode if the sequence doesn't work. Then you get into level 2, which is what we call conditional autonomy. So you target operational tasks to be performed by an automated system without any human interaction at all, but the human performs the remaining task, and the human operator is always responsible for the safe operation of the vessel. So power management systems is a good example, where the power system is looked after automatically by the machine, but there's always a human on hand that can drop in and take control if he doesn't like what's going on. And the low-level DP0, DP1 systems as well, that we find dynamic positioning systems as well, would fit into that particular line. And then level 3, you get into high autonomy. So this level, you're getting a lot of automated tasks without human interaction. The human operator performs the remaining tasks, but the system is responsible for safe operation. So if you think of a dynamic positioning 3 system, a lot of automation and safety is bestowed in the system to do that. So you actually see in the marine industry, we've been embracing a lot of this technology for many, many years. It's just that we haven't really called it remote and autonomous shipping, but actually we're doing a lot of it. And then the final level is full autonomy, and at that point, you're bestowing everything on the machine. You may still have a human that might be overlooking and overseeing, and maybe can dip into things if things don't go right, but that's the ultimate that goes on. So before we get into why, let's just talk a little bit about, what do we mean by remote and autonomous shipping? What do we mean by the architecture that supports it? So it's no longer just the vessel. We now have a complete enterprise, because you've now got shore-based, as you saw in the video. So there are people on shore, there's machinery on shore, there's decision-making being done on shore, and then you've got the vessel or the vessels as well. So you've now got a complete enterprise. And there are a number of features that are in there. So if we start with situational awareness. So first of all, you need some sort of intelligent awareness system. So some sort of sensoring system that's looking, what's around the vessel to help it with guidance and navigation, such that it can acquire targets, and it can know what ships are around it, what buoys, navigation lays are around it, where the shoreline is, etc. And then you've got an automatic navigation system, or an autonomous navigation system, which is effectively the captain or the master of the vessel. And we're developing a system which is going to be based upon artificial intelligence, where we'll take things like the collision regulations and we'll codify them. We'll take whatever customers' best operating practices are, and we will codify them. And then we'll take the master's tacit knowledge, which tends to be in their head, because even when people write down their operational knowledge, they don't always use that. They operate the vessels in different ways. So what we want to try and do is codify that from what's inside the master's head. And then the artificial intelligence systems, then once it goes live, it becomes better and better at taking that. And you can do some processing off board, and then you can re-download the model whenever you like, based upon different operations within the fleet as well. And that's the automatic navigation system. Dynamic positioning systems are fundamental. So we build our platform on our DP system. The dynamic positioning system actually has a model of the performance of the vessel. That's what it was designed to do. It's designed to know what will happen to the vessel in 1 or 2 minutes' time. It knows the state of the equipment. It knows what it's capable of through its capability diagram. All of that is modelled, and it allows you then to provide actuation signals to the thrusters or the steering system or whatever to control the vessel. Then we have something called ACE, the autonomous chief engineer. This is something that we're developing now. We're actually trying to come up with the ideas about how do you automate machinery, but also how do you interpret what's happening on machinery? Because we don't have anybody on board in the machinery space. Now, chief engineers rely on not just their eyes, but their ears, their noses, the touch and the feel that goes around them, and the instinct. So how do you codify that? That's quite an interesting question. But we're going to have to do that if we're going to make this technology work. Then you've got everything else around the machinery, so energy management, equipment health monitoring. This is all pretty standard stuff that people are doing today. You can get that today. There are sensors fitted to equipment. Every engine that goes out the door from any of the big OEMs has lots of equipment, lots of sensors fitted on board. There are models of that engine, and as engine manufacturers, we pretty well know what's going on with those engines. And now we're bringing in predictability into the component design, so we've got predictability about the performance of the components as well. Then on the shore, you're going to have, effectively somebody supervising the operation of the vessels, and you're also going to have maintenance people, effectively the equivalent of the chief engineers on board, and subject matter experts that can intervene as well. So you've got the remote operating centre. All of that is connected together through some sort of communication medium, and there will be diversity in that communications medium. We will not just be relying on satellites, radio signals and wireless and 4G when you're near to ports. All of these will come together, so there will be no single points of failure within the system. So why do we want to go into remote and autonomous shipping? What's wrong with shipping today? Well, there's nothing wrong with it today, but there is always the challenge of bringing the costs down. You know, people want their goods at lower and lower costs. People want to make money out of their operations. So where we're going with it is actually, if you take the cost structure of cargo, annualize it, and you look at the different categorizations of things like fuel and capex, with the amortization of capex, the manning, the insurance, you know, the maintenance costs, the C&A charges that go together. Remote and autonomous shipping actually tackles probably around about 3/4 of the cost. It will make an impact on some of those costs. It's not going to reduce them to zero. It has an impact on all of those, and I'll go into that in a bit more detail now. So first of all, the studies that we've done show that actually the transportation cost of cargo is up to 20% or maybe more cheaper using remote and autonomous vessels. And I'll go into the reason why. So this is the cost per tonne per nautical mile. All of this is contributed by the fact that, you know, potentially we're going to be saving fuel, the vessel itself could be cheaper, and we can carry more on the similar size vessel that doesn't have people on board. So that's the first one. And the annual cost of shipping around the world is around about 350 billion. And if we applied unmanned vessels to about half of that, then the annual saving to the industry could be something like 35 billion a year in saving on transportation costs, as it were. The other thing as well is that this could have a significant contribution to the reduction of CO2 emissions as well, because we're going to be saving fuel. And you have to remember that the IMO has an ambition by 2050 that our industry will become carbon neutral. So this is not the panacea, but this is one of the many other technologies that can be brought to bear to help us get down to that level without having to go into carbon trading and sort of offset ourselves against other industries which are really good at doing it and we're not so good at doing it. So how do we save energy? How do we save emissions with remote and autonomous vessels? So first of all, I'm going to take everything to do with people off that vessel. So anything that requires life support, I no longer need. I no longer need to put it on the vessel. So that's going to lower the dead weight, for instance. No more cabins, no more galleys, no more machinery, water evaporators, no more sewage plants, no more heads. Those all go. That's going to reduce the power on board as well. So the electrical energy on board, only a modest amount, but still, you know, it could be something like on a vessel like this, a 20,000 tonne dead weight bulker or general cargo vessel, that could be a couple of 100 kilowatts. And we can also get rid of the superstructure on board on top, so that reduces wind resistance as well. And we can also do a little bit of work around the naval architecture to make the vessel that much more efficient in the water. So all of that adds up, and that's why we can save fuel, and therefore we can save fuel and emissions as well. So some of the features of autonomous vessels. So first of all, for the same size vessel that carries people and cargo, you can get more cargo on board. There are no hotel systems, you've got no deck house, you've got a lower power demand, but you might have to put redundant machinery on board. So there may be an increase in cost, and you're going to have to put additional sensors on board to replicate what humans would be normally looking at. It might be CCTV, it might be additional pressure and temperature sensors on some of the equipment. So there will be some form of increased cost related to all of that as well. But on balance, our view is that you'll end up with a vessel which is simpler, which is going to be more affordable, and it's going to require less fuel and create less emissions. So if we look at the evolution of an unmanned vessel, so if we strip a vessel back, so first of all, we no longer need the superstructure. The wheelhouse goes, so all of that accommodation, the galleys, the navigational bridge, that all goes. The next thing that goes is all of the your sort of lifeboats, the davits associated with it, life buoys, anything like that, that all goes as well. Then you're going to get a simplification of a lot of the machinery. You're not going to need sewage systems, you're not going to need water generation, you're not going to need stores for food, and air conditioning is going to be reduced on board as well. So all of that goes. So that makes the machinery much simpler, as it were, which means that you can do a little bit of naval architecture. You're going to rebuild the machinery spaces slightly differently. You're then going to have to put some sort of masting up there to carry the communications and sensors, which will probably be a little bit more than a conventional vessel. And you put that all back together again. There's probably some work that you can do around the hydrodynamics and the lines of the vessel as well. And you've got yourself an unmanned vessel. And you can paint it as well. So which types of vessels are going to benefit from the technology? So I've divided it into 3 types. So first of all, there are a number of technologies that we're developing in remote and autonomous ships which will be applicable to all types of ships, even though they continue to be manned. So to give you a really good example is what we call intelligent awareness. So this is increased sensor systems that can be put on board vessels. The cruise ship industry are really interested in this to allow watchkeepers greater situational awareness around them, especially when they're operating in ports, and to reduce the incident of running into anybody else or anything else, as it were. So that's the humans still being involved, but this time the technology is there to help the humans, as it were. Then you've got all the benefits that are coming out of all the data analytics and insights around equipment health monitoring, around prognostics, predictable design, that will aid to the availability of equipment and moving more towards availability contracting. One of the big drivers in aerospace that's driven up the reliability of aircraft design is actually making the risk on the provider of the equipment. So as an engine manufacturer in the aerospace industry, we take the risk of that aircraft being available and being dispatched. And if it's not dispatched, if you get on that aircraft and that aircraft cannot fly because there is an engine problem, then we will be paying millions of dollars in penalties to the airline because our engine failed to work. And what we find is that we've made our engines more and more reliable because of that contracting mechanism. We're transferring the risk to us to do that. And we're beginning to see that coming into the marine industry, where we're looking at availability contracting. So customers are coming to us and saying, okay, then put your money where your mouth is. You take the risk on that equipment being available to operate. We come up with a contracting mechanism with them, and hopefully it will drive more and more reliability within our industry. The next area is those vessels which will benefit from reduced manning, and actually the majority of vessels will benefit from reduced manning. And this is where we bring greater degrees of automation, both in navigation and also in the machinery systems as well. And then we get into unmanned vessels. So this is where we put in the features of artificial intelligence to do navigation systems, remote operating sensors, and more sophisticated dynamic position systems. So the vessels which we think are going to be the ones which will benefit the most from it are things like bulkers and general cargo and feeder containers. Quite a number of vessels in the offshore industry, and I'll come on to some of those a bit later. Things like road ferries and ro-ros as well will also benefit from the technology, as well as tugs. One of the ones that we think probably won't actually benefit is when you get to very large containers. You know, the space accommodated for human beings on those vessels and the fact that they are so big and so immense probably doesn't warrant us going over to remotely operated vessels, not in the medium to long term. Other vessels which might be carrying dangerous cargoes as well. We can already see murmurings coming from people like the US Coast Guard and others that they're not going to want remotely controlled LNG carriers around their shores. Not certainly without them being in control of them for a start. So those types of vessels, we probably won't see any need for them to go to this extreme of being unmanned, as it were. So what are the technology development areas that are still to go? There's still a lot to go, and as I said before, for remote and autonomous vessels, it's an enterprise. It's not only the vessel, but it's also the communications. It's also a land-based system as well in the remote operating control centre. A number of areas that we have to concentrate on. Cybersecurity. Quite often I'm asked about cybersecurity. What if somebody can hack into a vessel? And we'll come on to that a little bit later. Reliability and safety, that also comes up, so we'll deal with that one a little bit later. Intelligent awareness and connectivity and maintaining connectivity. So there's a number of big challenges that we still have to go on the technology side to see this as a reality. Let's start with reliability. Often, we're given the challenge to say, well, actually, on our manned vessels, you can't make them reliable enough with even people on board, let alone when you take people off them, as it were. One of the key things here that I think is coming is around what we call predictability. So there is more and more, we're using predictable-based design methods where you can look at components, you can know its material characteristics, you know how it's manufactured, you know its critical features, and you can predict the failure modes of that particular piece of equipment. So if you take, for instance, a motor car, the oil pump is designed for around about 3,000 hours of operation, and then it will fail. It's actually designed that way to get you through to that particular service that might be 5 or 7 years into the vessel's life based upon normal driving. We do it in the airline industry, aircraft engines and certain components on aircraft, they're designed to have a predictable life. You can make it unlimited life if you want to, but it adds weight, it adds cost, it adds complexity. But you can identify critical features, you can put finishing on them, and you can get very predictable designs now. And we can get the battle curve away, and we can know, statistically when that particular component will fail. So things like predictable design is going to be coming in. Then you've got things like health management. So putting additional sensors on board pieces of equipment, that gives us insight into how that equipment operates, and then we can then determine how we can make the designs even better. One of the challenges quite often is that as an equipment manufacturer, we get a specification which comes from the shipyard, and the shipyard have made an interpretation of what the owner wants, and then the owner gives that ship to an operator, and the operator operates it completely differently. Quite often our equipment is operated in a way that we didn't actually envisage. It wasn't designed to operate that way, and then we get failures as well. The good thing about remote and autonomous ships is that there is more predictability in the way that those vessels are operated. And in fact, the whole fleet will operate in a very similar way, in a very predictable way, and we will know exactly why it's being operated that way, and that will make the designs better and easier to do. Digital twinning is really where you take a model of the vessel, and you can take a whole model of the vessel now. We've got all of the structures, all the material properties. You can model that in FE analysis. And you can get very, very cheap computing these days, multiple processors, high performance computing. And actually, next year I'll have my design team having access to 40,000 high performance computing cores, 2.4 petaflops of processing power, where we'll be able to do hydrodynamics and FE analysis on equipment, on propellers, on ship designs. And that will revolutionise the way in which we do design and understanding of design, and the way that these vessels actually operate. Then we come on to cybersecurity, and it's going to be crucial for any remote control vessel that you can stop threat actors actually intervening, and there's a number of ways in which they can do that. Actually, the current level of cybersecurity in our industry is actually very poor, and if you talk to any of the experts, they will tell you that today, most vessels carry some malware on it, and one of the reasons that the malware doesn't actually activate is because the data rates back to shore are so poor through the satellite links that the malware can't be activated. But actually, once those broadband links open up, we'll see more malware attacks on our vessels, because people are coming on board with data sticks, unvalidated PCs, they're connecting it to the networks on board the vessels. Those vessels' networks are not updated with the latest virus check-in or firewalls, and they are a big threat. And so the challenge is there in the industry anyway, and we have to address it. There's a misconception it's all about connectivity, but as I talked about, people come on board vessels, they come on board with data sticks and disks and other things, and they load them up. And you can also get the threat coming through supply chains. I can get a component that will have some software on it. How do I know that that software doesn't contain any malicious viruses? So I have to then work out whether that supplier is from a trusted source or not. You can get that coming through the supply chains. You've got a very complex architecture on board vessels as well. So you've got maintenance networks, you've got the power management system network, you've got the propulsion control network, even the voyage data recorder network, AIS, lots and lots of different networks on board, all of them requiring some degree of regular updating, as it were. So first of all, you have to maintain confidentiality of your network. You have to make sure that the data on there is kept away from people that don't need to know about it. We need to keep the networks on board up, so that's the other area that we work on. And then you have to maintain the integrity of the data. So our strategy is of one which we try and understand the changing landscape around us. There are threat actors out there that will always try and stay one step ahead of you. So this is going to be a continuous battle. There is not going to be one way of solving this one. Just to give you an example, on the CSU project, which we'll talk about a little bit later, which is the remotely controlled tug, we actually got F-Secure in to actually come and try and hack into that vessel on our remote operating centre. They spent 2 weeks doing it. So we had 4 guys, all with hoodies on. We must have been paying them in donuts and coffee, because that's all there was in the kitchen area. And they spent 2 weeks trying to hack into the system, and they weren't able to get in there. But all that tells me is that my surface perimeter is secure. But what happens when I get a disgruntled employee who actually operates on that tug, or a disgruntled maintenance person as well? So, you have to have layers of defence within your infrastructure to do that. So anybody who's involved with cybersecurity in buildings and businesses will know this, and you also need your business continuity. What happens if something does happen in? How do I recover the situation? And how do I make it safe and get back to operations as well? I don't have all the answers on this one, as you can see. The next area is safety. So, and a fundamental question for somebody like Rolls-Royce with such a prestigious brand name is, can it be trusted? I'm actually the guy that goes to jail or stands up in court if we have a product safety problem. So I don't look very good in orange. So I delegate a lot of my safety down to my team. I have to trust them, and we have to challenge ourselves all the time. So the way that we're bringing this technology to market is we're doing it in 3 different ways. So first of all, we're pioneering some of the technology around advisory systems. So our intelligent awareness system is there as an advisory system to enhance the safety of the watchkeepers and the crew on board, but it doesn't take decisions for them, as it were. The next level then is what we call control, where we actually use those information systems and sensor systems, and we bring in more automation, and I'll explain some of that a little bit later. And then finally we get into the autonomous technology. And we use a principle called as low as reasonably practicable. So if any of you have been involved with safety in defence or in the nuclear industry, you'll be very familiar with this term. So what we do is there are 2 key words there: reasonably practicable. So practicable means I can actually do it. The laws of physics and science and technology says that I can do it. Just because I can do it doesn't mean to say that I have to do it. And the word reasonable comes in because it has to be balanced against the cost of doing it versus the benefit that you get. Disproportionately, I could be hit by an asteroid as I walk along down the street, and I could wear a lead helmet, but I'm not going to do it. The risk is so low, it's not really worth wearing that lead hat. So we apply a very similar principle to safety, but that's what we're doing. We're doing a risk-based approach to it. We use safety cases. It's something that the marine industry often resists. Now, a lot of equipment manufacturers, they like prescriptive rules. Tell me how I can demonstrate this equipment is safe to go to sea. I'll meet the rules, and I'll give you a conformance certificate, and class will come in and give me a tick in the box. For this technology and for future sophisticated systems, whether it's manned or unmanned vessels, we cannot afford to do it. Prescription will not be able to keep up with the rate of change of the technology. And I'll tell you that for a start, that actually the classification societies, they do not have the domain knowledge to keep up with this technology. They are struggling to keep up with it. Ask any of the class societies, they are losing key knowledge, and they have to keep up with the technology. Part of what we're doing is bringing the class societies with us. So we'll talk about that, and actually I've got a video later which will explain that in more detail. So we get on to rules and regulations. So this whole sphere is unregulated. At the moment, I cannot take an unmanned vessel, a large vessel that is, I can't take that international waters. That's prohibited. The IMO says that it has to be manned, you have to keep a watch keeping, and then if you have to then go and you have to come to the aid of another vessel that may be in distress, that's the imperative for being at sea. So at the moment, IMO prohibits it. Now, that's not to say that we cannot use unmanned and autonomous vessels within any country's waters, because a flag state can then take a decision about whether they will allow that type of operation in their waters. And actually a number of flag states around the world are quite excited by this technology and are actually actively helping. So if you go to places like Denmark, you go to Norway, you go to Finland, you go to Singapore and the UK as well, then those flag states are actually really wanting to see how this technology works and learn alongside the industry as well. The class societies are working very hard. There's been a rush to get the cyber-enabled ship regulations out and shipwright regulations, and everybody's got their own cybersecurity code. Everybody's got their own framework for autonomy. There has been a race to get something out there. You cannot be left behind. But actually what's coming out isn't really a great set of helpfulness for us in our industry. The ecosystem of rules and regulations out there, the guidance isn't really that helpful. And the industry needs to begin to work together and work with the technologists and work with the owners and operators to actually get a decent set of rules and regulations in place. So the journey to autonomy, it's been around for a long time. I could actually take this chart back to 2003 when we started doing dynamic position systems, and people like Kongsberg and GE can go back many, many years, back to the 1960s when dynamic position systems were invented. So the journey to autonomy has been going on. We've had automatic start sequences for engines. ECDIS could be said to be a primitive sort of situational awareness system. Blending data from different sources together, as it were. But for us, it sort of started around about 2013 when we started our own internal vision with some research work that we did. And then really in 2015 when we did the AWA project, which was a project we did in Finland with FIMFerries, and we're still doing the AWA project, that started working on, could we actually automate a ferry and take that to operation? And that project's actually ongoing. And that will bring an autonomous ferry to operation. Then last year we opened our R&D centre. We actually put that video out there in the vision. We sort of launched a number of other different initiatives, working with a number of different customers around the world as well. And slowly the industry became more interested in it, and a lot of our competitors came along and they've now started doing some work. So Kongsberg are working with Yara now in Norway, which is a fertilizer vessel, which will be the world's first automated, autonomous, coastal bulker, as it were. There's a program going on in China at the moment with HNA to build an unmanned cargo vessel, which should be in the water by 2020, 2021. Wärtsilä, they had a remotely controlled dynamic position vessel in the North Sea, controlled from the USA. So everybody's now coming into this space. So the technology is now really beginning to go forward, and I'm really, really glad that other players have come into it, because competition is something which breeds innovation. You want a competitive marketplace out there. For me as a technologist, this really drives me, and I love it when the competitors are there, really driving me and my team harder and harder, because we have to become more and more innovative in the way that we approach. This year, we signed a collaboration with Google Cloud. We joined forces with them using some of their vision processing software to help us on situation awareness. We just signed an agreement recently with the European Space Agency, because actually equipment and satellites that have gone into space are autonomous. So they've actually solved the problem. It's been solved since the 1960s when we started sending satellites into orbit. And you only have to look at the Voyager satellites. They're still out there now transmitting and being able to be controlled remotely, and they're being controlled with systems that take many hours to actually get a signal to them, and are still providing useful data to us, as it were. So some of the people in other industries have actually solved some of the problems we're looking forward to. The question we're always asked is actually when are we actually going to see these vessels in service? So by 2020, I sense that we will see the world's first commercial operated remote control vessel. That will come. It will either be the Yara vessel, it will be something that we do, or another company does, but it will come. Local flag state will authorise it, it will be around a port or something like that, and it will be there. Probably by 2025, we'll find some more remote controlled and autonomous vessels around inland waterways, tugboats in ports and harbours. As I say, anything that will be operating around the coast. It could even go between two countries where the two flag states come together and they come to an agreement. So you can see a place like Norway, Denmark, Sweden, Finland. That Baltic region is a ripe area where we'll see transportations, quite innovative thinking flag states there. But we won't see the ocean going until 2030, and the biggest inhibit there is really the IMO. So we will not get an international set of rules that will be agreed probably for 10 years. It just takes that long for it to happen. So we have to be very conservative about the international use of this particular technology, but it will be pioneered around coastal waters and inland waterway, which is great because that's a big market. You know, we've got 4G connections next to coast, we've got lots of connectivity, we can get to the vessels very, very quickly. It's a complex area, so target identification is going to be really challenging. So if we can get it working in the coastal waters, inland waterways, by God, it'll be pretty straightforward when we get to the open oceans. So let's just talk about our first automatic control system. So this is the Fjord 1 ferry, and this is actually coming into service. This is being commissioned now. And this ferry has got what we call an auto crossing system on board. So it does a crossing every day, several times a day between Ande and Lotte in Norway. And it's a 1.3 kilometre crossing, so it carries cars with people, as it were, and it will have a master on board, but it will have effectively an autopilot system on board which will control the speed and the direction of the vessel, and it will keep it to a particular track. It will take into account the wear and tear on the vessel, and it will allow it to be manoeuvred very close into the dock, and then manually the captain will take over and he will berth and he will unberth the vessel. And then next year we'll perfect the software to allow automatic berthing and unberthing of the vessel. So let me just show you a video of the concept.
Our latest contribution to ferry efficiency are the auto-crossing and auto-docking systems. The auto-crossing system is designed to minimize energy consumption by repeating the most efficient journey through acceleration, transit, and deceleration towards arrival quay. The auto-docking is an extension of the system and will further automate ferry operations for reduced time and energy. The auto-crossing system engages thrusters as needed for the acceleration, transit, and deceleration performance. The system will optimize the energy consumption by adjusting propeller pitch and RPM and the power distribution between the fore and aft propulsor. Prior to arrival, the system will automatically decelerate to prepare for docking. The captain will resume manual command inside a predefined zone and maneuver the ferry to quay. If, for some reason, the captain doesn't take control, the vessel will automatically come to a stop in a predefined location using dynamic positioning mode. If the optional auto-docking system is activated, the vessel will automatically go to dock using sensors and transponders that interact with the vessel's dynamic positioning system. For battery-powered ferries, an automated system recharges the batteries from the land-based electrical grid to prepare it for the return journey as soon as safely docked.
So that's something that we will have operating in the next few weeks. We've got, excuse me a second, we've actually got the 10th one of those on order now. So by the end of 2019, there'll be 10 of those ferries at least in the world that will have that auto-crossing software, and it will move across to the auto-berthing as well. So couple that with the battery technology, which the Nordics is now deploying because they're going for zero emissions around their coastlines. We've got a very green and automatic solution with no carbon emissions because, of course, all the electricity comes from hydropower on their grid, as it were. So a very neat solution, and keeping communities connected together. The next stage then is intelligent awareness. So let me just show you this quick video. So this is a system that we're developing. It uses multiple sensors. So we're using LiDAR systems. So this is the sort of systems that are used, similar to the systems that's used in autonomous autonomous cars, but actually we use the systems that are used on the back of naval vessels to guide helicopters and aircraft on the back of naval vessels. So these are marinized LiDAR systems. So it's a laser. It will map out the situation around it. We have pan and tilt zoom cameras, day-night cameras, infrared cameras, and then we blend all that together with radar signals and AIS to give us an unprecedented situation awareness around the ship. We're training this system. We're also we're doing a trawl of the internet, and we've downloaded 5 million pictures of vessels, and we're actually we've got an AI system which is doing a target identification of every single one of those vessels. So we'll be able to do an identification of any vessel that's on the open seas, as it were, today. And we're actually going to be training the algorithms using our simulators as well. So as well as sending these things to sea, you're never going to get enough data. So the best way of doing it is to use some of our very sophisticated simulators and to use that to train the algorithms to do target identification, to identify buoys, flotsam and things like that around us, as it were. So the intelligent awareness system is going to go through a number of evolutions. So we're getting a minimum viable product out to market next year, in the early part of the year, and then we'll continually evolve that, as it were, and that would become part of the core of our remote and autonomous vessels. So lots of customers are interested in this one just to enhance situational awareness on bridge, but then it will then become a fundamental part of our vessels. Then we've got the remote operating centres. This is an interesting area because a lot of people have been concentrating on the vessel, but we're doing a lot of work on what these remote operating centres are going to look like and feel like. We've brought in masters and chief engineers to help us, design them, and it's not a computer game. These are not computer game consoles. First of all, we've got a number of different modes. So first of all, you can actually operate a vessel manually in a sort of melee mode, so a gaming mode. So you can actually move the joystick and the vessel will move, or you can go to a more tactical mode where you can command the vessel to do a particular set of simple manoeuvres with a human watching over it. And then you can get to a strategic mode where it's actually an operational centre, a bit like an air traffic control system, where you give full authority to the vessel, and you'll get alerted if it's not following that full authority, as it were. So you've got strategic, you've got tactical, and then you've got the melee mode as well, and you've got to cater for all of that. The other thing about remote operating centres is who's going to regulate them, because this is a land-based system. So is it the purview of the IMO? Is it in the UK? Would it be the Health and Safety Executive? Would it be local building regulations? So I imagine security services are going to be interested in this, in terms of national assets. So actually, we're now going to have to engage with a number of different regulators with all of this. What about the training? What about the people that go inside them? Are these going to be people that are seagoing people, or is it going to be people that are very good at doing, sort of first-person shooters that are very good at controlling things? These guys that play computer games now are very, very good at controlling first-person types of applications. You send them into a ship, on a simulated ship, to go around the compartments. They'll get around those compartments quicker than any of us, who is a chief engineer on board a vessel, can manoeuvre it with a joystick. These guys will get around it very, very quickly. Very interesting area. I could talk about that all evening. And what we're going to also see is we're going to see new designs. So it's going to open up the design space, and this is an area where I think we're only really, really scratching the surface. So platform support vessels. These are the workhorses of the North Sea, taking supplies out to rigs and operational plants. These are manned vessels. It's pretty aggressive conditions out in the North Sea, but you could send a small autonomous vessel out there. You're not sending people to sea. There's no safety issue there. They have dynamic position systems on board, and the cranes on board the platforms can then take the supplies off, and then the drone can come back. It could be a very effective way, especially with the oil price being very low. You've got the oil companies really looking at how can they make money off of offshore platforms when the dollar price of oil is around about the $40, $50 or $60 a barrel, because that might be the new norm. Then you've got subsea lift. One of the areas there is, why can't you just have the crane operators working remotely? So why send the crane operator to sea? Why can't you have them operating? You can have a better utilisation. They're no longer having to do long passages, then do the operations at all sorts of ungodly hours. They could do that from shore. and they can do many more lifts. ROVs can be operated underwater from a mothership, which could be unmanned. You no longer have to send all the crew with it as well. So again, you're looking at simplification of that operation, and you're looking at driving the operational costs down as well. Autonomous tugs. Any of you that have ever worked in harbours and ports will know that tug operation, haulage and towing is actually quite dangerous. There are lots of seamen that have been lost or injured in that particular operation. If we can automate that, that's probably the most challenging automation problem that you could have. If we could do that, then that would open up the space and we'd really demonstrate that the technology could work, and that's what we're working on at the moment. Naval, Naval have been doing sort of mine countermeasures and surveillance for many years using autonomous, but now we're thinking about it for bigger vessels, and this was a concept that came up for a logistics type vessel. Could be used for launching drones, for doing covert operations, Coast Guard duty, constabulary type operations. But certainly the navies are getting more and more interested in it. The US Navy have just put out a tender now for something called Overlord, where they're looking to take a conventional vessel and looking at making that autonomous, as it were. We talked about ferries earlier. I won't go into that in more detail. And then you've got the bulkers and containers, and you can get into low-cost smart shipping. We've got some concepts there. You can go onto the internet and onto YouTube. We've got something called the Electric Blue concept, which is a configurable, low-cost point-to-point container feeder vessel, which you can refit with different propulsion systems and different configurations, manned or unmanned, as it were. And then even luxury yachts. So let me just indulge you for a second. So this was a concept that we launched a couple of weeks ago. Taking orders. One of the ideas we've got as well is that the dynamic positioning system will be fitted. So normally we don't fit DP systems to luxury yachts, but actually you can manoeuvre the vessel to follow the sun, so you get the best sun tanning on the top deck, as it were. So I don't know whether we're patenting that idea, but it's a novel idea. So how far are we on the journey? So actually we're beginning to make some good advances, and a number of the different equipment guys are making advances, and we were honoured last year to be selected by IMarEST to work with them on could we actually remotely operate a tug? So that was the challenge that was thrown down, and they went around the world and talked to different vendors, and they came to Rolls-Royce, and they felt that we were sufficiently advanced and ahead of all the rest that we could work with them to do this. So what they did is they donated one of their tugs, which was built at Sandmar last year. It was a 70-ton bollard pull tug, so it's a pretty big, heavy-duty tug, as it were. And it was built up in Turkey, and then it was transferred to Copenhagen, and we fitted a lot of our remote equipment to it, DP system to it as well, and we did some operations with it. So the program itself was over 6 months, so it was a very agile design. So we had a team of about 20-30 engineers working with the Svitzer guys. We had to do operational studies, concept designs, all the detailed design, do the installation, commissioning, and then we had to do the verification and validation, and we came up with 400 different safety and functional requirements, which we then had to validate. We had class working with us as well, so Lloyd's Register were working alongside us. We developed a safety case for the vessel, and then we went into the demonstration. And what we were trying to do is we were trying to develop 5 key areas. So first of all, connectivity, so communications and connectivity. We were looking at cyber security, the situation awareness, and trying to enhance that for the remote operator, to build up a remote operation station, and also to work with a dynamic positioning system, which was what we call an all-speed dynamic positioning system. So it's one that can operate over the complete range of the vessel, as it were. This is a video of the actual operator. So there's a master mariner sitting in the chair there, operating the vessel. He's operating it remotely. There is still a crew on board the vessel. So in the event of an emergency, that crew can then switch over to the onboard DP, and they can take full control and full authority of the vessel. And that was part of what the Danish Maritime Authority, in terms of their prerequisites to allow us to operate. What you can see there is a 180-degree video wall, where we bring all the video feedback of what's around the vessel, and as you can see on the left and right hand side there, we've got sort of wing mirrors, effectively cameras, which are looking down the side of the vessel, which help berthing. We bring up some augmented reality here in terms of the thruster directions and RPMs, as it were. At the top here, you've got a LiDAR system, and we've also got our pan and tilt cameras, and that can be translated into infrared cameras as well. We've got an ECDIS system here, a dynamic positioning control station, and then the vessel automation system there on the right hand side. And then the master mariner has got full authority of the joysticks that are controlling the thrusters. The latency of the system is less than 700 milliseconds. We actually found that if it went anything above that, then the responsiveness was something that the master mariner didn't like. So we looked at the latency effect as well. And then one of the features we had to enhance was actually they like to hear the sound of the engines. They like to hear the throttling up and throttling down. So again, we put microphones on board, and we've got speakers there, because the haptics are going to become quite important, because when you're not on the vessel, you've got no motion. It becomes a bit of a video game, as it were, so therefore you need to bring some realism back to the master mariner to give them some of that better situation awareness. The distance that you find between the chair and the video wall helps, so that depth perception is helped by that distance. We found that out in our simulators when we worked with our simulators. But what you find is one of the biggest complaints was actually depth perception, because you have 2 eyes, which gives you the stereoscopic vision. You don't actually get that, so you have to provide, this is where situation awareness with the target identification, when we overlay that, will actually help in actually working out how far something is away. But that was one of the sort of the complaints in terms of operating this that we got back from the operators. But the whole idea was to demonstrate the technology and to demonstrate it works. Now, connectivity was provided by telephone signals, so 4G. So we had 4 4G systems that we installed on board the vessel, as well as satellite communications, and we had wireless systems as well. And that was all brought to bear. Quite a lot of data was transmitted back to get that high definition video, but we're actually working on getting compression down from 40 megabytes down to something in the order of about 4 megabytes. Such that it's not such of a burden on the communication systems, as it were. And the training required, it only took a few hours for the master mariner to get used to the system, and within a few hours he was berthing and unberthing that tug himself. Okay. So that's the actual bridge, and as you can see on board, it's quite a complex bridge. There's quite a lot of things in the way of you, as it were. Your view is quite impeded. And one of the positive things we got back was that the remote operating centre provided a better tactical visual picture than actually being on the tug bridge itself. So actually that was something that they really, really valued and they really, really liked. So that was a benefit that we hadn't really spotted before. The demonstration was quite straightforward. So we did this with class, we demonstrated this to the DMA, and we did it to some of our customers. And effectively, we basically unberthed the vessel at the quayside next to the Sixer offices. Then we took it for a little bit of a walk down Copenhagen Harbour. We moored it alongside and then brought it back. And that was all done under remote control. Obviously, there was a crew on board if there was ever an emergency, but there was never an emergency case. But we did all of that, and we claim that that was the world's first commercially operated vessel that was remotely controlled. So why don't I get some of the guys to tell you about the project.
CISO is a very important milestone on our journey towards remote autonomous ships.
Project CISO is a collaboration project with Switzer, one of the largest duck companies in the world. There we have demonstrated our capability for remote operated ducks.
So what we demonstrated today was the Rolls-Royce Remote Operating Center. The massive screen behind me is what we call the video wall of the view from the vessel.
Lloyd has been involved from the initial days in the concept of the CISO Optimus project, really helping define the end user's requirements and working in close collaboration with Rolls-Royce and ourselves to help de-risk the project and to fulfill the requirements for safety and reliability for a safe and secure demonstration of the vessel. This was a team effort. This was a partnership with Lloyd's Register, the end user, and Rolls-Royce to help overcome the technical challenges, to deal with the innovative technology that has been presented to us, and to ensure that we could deliver a safe and secure demonstration of the vessel.
So CISO is the demonstrator for the market and the world that we are not just about talk, but we are also about doing it. And we are the first in the world to have a remotely operated vessel and introducing our own technologies to do that as well. It's been really good test for our team on the development side, just to highlight what kind of needs we have and what kind of challenges we face for future.
We have specially designed the sharing controls to heighten the captain's feeling of controlling a ship. It's very important that the captain feels that he's in control of the ship and not playing a video game. In today's demonstration, we showcased remote maneuverability, we showcased object detection and tracking, and we showcased a pushing maneuver where the captain in the remote operating center controlled the vessel and gave another tug a little bit of a push.
The CISO is the first step and remote control is the first step toward autonomy, and our aim is to have commercial solutions for remotely operated vessels by 2020.
So for myself personally, this has been absolutely fantastic as an engineer to see from the initial concept that we sat and discussed with the end user in Rolls-Royce, to see this through the risk studies to de-risk the project, then to go through the validation and verification, and then successfully demonstrate a safe and secure cyber trial was fantastic.
We have demonstrated here today how we can safely operate a vessel from a remote operation station. The future of the marine industry will be very different than today. We're going to see a big change. The future will have a much more integrated marine industry. The ships will be integrated into the cargo owner's total business. The future of shipping will also involve more remote and autonomous ships that will be safer and more efficient than today's ships.
Oscar there, who's finished the talk there, he actually won the Lloyd's List Innovator of 2017, so it's a real delight to have somebody there working for me that has been given that particular accolade. So I'm sure you've got plenty of questions. I could talk hours about this particular subject, and we've not covered half of what could be discussed. I'll just put some pointers up there because there is a lot of challenges with this. Actually, I think the biggest challenges is probably not the technology, it's the acceptability of the technology, it's the legal, it's the liability, it's the regulation, it's the impact on jobs, it's the qualifications, insurance, you know, and there's lots of areas there. So I'm quite happy to take some questions now. And I'll say thank you very much for your attention. So thank you. We've got a question from the floor. Yes, please.
Barry Brooks, IMarEST trustee. Fascinating, looks very promising. A couple of areas which you didn't have time perhaps to dig into. There's the handling of ropes and cables, particularly for the tug. That's the ultimate manual activity. And secondly, bad weather, poor visibility control of the vessel.
Yeah. So rope handling is an area that we are now actively developing, and there's a number of patents that have gone in there. Actually, there's a number of companies that are looking at automatic rope handling systems. So I can't talk about it because it's an area that we're beginning to patent, but as part of the demonstrator on phase 2, we will be actually looking at fitting some handling equipment and looking at the automation and trying to demonstrate that to see whether we can productionise that and do it. So it's a really good question. It's an area that will have to be evolved, but there is quite a number of very simple ideas out there that could actually do that. You know, rope catchers that could actually do that. So,
sorry, the bad weather and poor visibility control of the vessel.
Well, I'm not sure what the question is, because I mean, if you look at vessels today with DP systems, you know, they're designed to handle quite bad weather, and they, you know, we know what the capability of the vessel is, we know how it handles in bad weather, we know what happens when you have a thruster out or you have reduced power. So you've got very good ship models, and we can build those models very easily, and we can put them into simulators to test them and validate them and verify them. Well, I think one of the challenges will be target identification in bad weather rather than the manoeuvrability of the vessel.
That's what I meant.
There are a number of companies that have already done this. So if you go and talk to people like ASP here in the UK, they suffer from the vessel being very small vessels. Actually, the sensors actually disappear below the waves in certain sea states and then come back up again. And again, you know, they've developed a very reliable technology which will know actually where the targets were, even though you only acquire it sort of every 11 seconds as you heave up and down in the waves. So, you know, so yeah, it can be done with even quite low resolution sensing. So I think the question there first. Yeah. Yes.
Thank you. Name's Alan Graveson from Notice International. We're a trade union professional body representing masters and officers. Been around for a long while, since 1857. We've seen technology come and go, and arguably we've always argued for improved technology to lift the load, lift the burden. And I'm very impressed by what you presented today. We've had our discussions, and we are very much in favour of this as an organisation internally. Others are not around the world, and there's a lot of resistance building up, as you would expect. Probably because our members, which many are IMarEST members as well, are at this high risk, high value end market. Now, that's sort of statement observation. One area which we're looking to this and what people feel is if there can be a transfer of jobs and employment from where is high risk and dangerous, which we've seen at sea, to actually to be more land-based and more safe and secure. Removal from the 91, 98, or in case of the master, the 168-hour on call to ashore can be quite liberating, and also remove the what is almost, I guess, a slaughter with the injuries at sea that do take place, not just the deaths. If it can be sold in that way, it can be absolutely excellent. In that context, how do you see the development ashore building up? Surely you're going to need repair yards and manufacturing facilities for all of this. How do you see that building up? Will it be in key hubs, as in the aviation industry, key hubs around the world, or more scattered?
I think it's going to be scattered, because if you think of shipping, it is global. It happens everywhere, and actually the repair and overhaul of vessels, it will change a little bit, but actually there'll still be requirement for fitters, welders, you know, as well as, you know, software engineers to go on board and reprogram things, etc., etc. So I don't see too much in the way of that fabric changing. I think actually the yards that are there today, there'll probably still be the yards there today, tomorrow, doing that particular activity. One of the interesting ones is, how do you make a autonomous vessel such that you can work on it. Because of course now, if you're making everything more compressed and compact, that could be a challenge, and you could get injuries, and you're going to have people with sort of telescopic arms, but you're going to have equipment around them. So that's going to generate innovation itself. But then you're also going to create new innovation and new jobs around the technology itself. And as I say, we've been recruiting R&D engineers, to help us design this technology. Governments are very interested in autonomy, so they're putting a lot of investment into it. So there's jobs coming up in PhDs and universities to help the early stage development of it. But yeah, I think one of the areas which I think most responsible operators are looking at this is, how do I take the human away from the hazard into an area where it's a little more safer for them, as it were. And if you don't have to send people to sea, then why do you send people to sea if you don't have to do that? And as you say, it's much nicer to go home to your family every night rather than every 3 months or 6 months. So yeah, and that's where we find a lot of interest, is that people are now thinking along those lines.
Thank you.
Yeah.
If I may, there's been quite a lot of questions that come in online as well. I'll try to. One of them was around what will happen to those that are at sea, and I think maybe that was kind of talked about just then. If I can try and combine a couple, if I may. So someone's kind of commented, but I think it then touched on another one. They said, you mentioned that the first autonomous trials will happen with the permission of local flag states closer to shore, although the risk here higher than those in the open ocean. Although IMO may be several years away from unified autonomous regulations, maybe class societies, designers, operators can work together to perform limited trials at open sea under controlled conditions. This may be a safer way to test systems.
Yes.
And then maybe this touches in on it as well. Someone said you spoke about ALOP previously, and what is, and this relates to acceptable risk levels. What would be the acceptable risk levels? Which regulator would determine the risk? And would this alert level be accepted in all waters? So maybe that's sort of...
Yeah, it's a really good question. So if you take, for instance, the limit of tolerability that the HSE apply, it's normally 1 death per 1,000 employees per annum is the limit of tolerability. So above that line it's intolerable, below that line you have to begin to make sort of really good arguments, and it's sort of graded around, sort of deep sea fishing, that industry, and construction, which tends to be at that sort of limit, as it were. And then the basic level of acceptability is 1 death per 100,000 employees per annum, and that's the limit of sort of basic safety, as it were. So actually within that threshold is where you'd make the argument around that, and that's common across nuclear industry and aviation and other industries. So I think that framework would work. And it's all about the it's the cost of the safety benefit that we're trying to balance. Is how much effort you put in based upon what the benefit you get out. I mean, we're all prepared probably tonight to get into our cars. Actually, jumping into a car is one of the most unsafe things that you can do. But in aviation, by God, if anybody gets killed in an aviation incident, then it becomes world news. So it's actually safer to fly per kilometre than it is to drive in a car, or be a pedestrian, or be a cyclist, because I'm a cyclist, and so I put myself at risk every Saturday and Sunday. So again, it comes down to the human being's sort of instinct and their propensity to take risks.
Okay, thank you. I've got another couple, but if we go...
John Wills, I'm a member
of
IMarEST. Thank you very much, Kevin. I'd just like to credit what I'm going to say by the fact that I'm a great fan of the pushing the boundaries here and I worked with Autonaut a couple of years ago, so it's fantastic to see how it's going and also how the regulation is going under the MAS regulatory working group in Cohort, the Maritime Coast Guard Agency. But as a civil engineer, I look at that picture, that tug, and there's an awful lot of moving parts exposed to the salty sea air, which are not going to have any sailors doing routine greasing and all that sort of stuff. Is there any effort going into looking at the resilience of that to reduce the manpower maintenance load?
Right. Yeah, and absolutely. I mean, that's going to be one of the keys. Is newspapers are going to be waiting for the first time these things break down or do something like that. So, you know, and even on that tug, you know, we've had to maintain some of the sensors. You know, the tug, we were not using some of the sensors for several months, and went through a sort of a Copenhagen sort of winter, you know, which can be, you know, which is not particularly gruesome, but compared to some parts of the world, you know, and you know, you need to clean things. You know, cameras need to be cleaned. Sensors need to be cleaned and polished, you know, so if you don't have people on board to do that, you've got to think of an automated way in which you can do it and wash it. But I think you can overcome those challenges, and I think it's by doing these demonstrators, we learn what the limitations are and what we can work on to overcome them. Without doing these sorts of demonstrations, we will then run the risk of putting things into service that are very unreliable, as it were. Yeah. And I think a lot of this technology, you know, I mean, if we can clean sensors up on height, you don't have to have, you know, on a manned ship, you don't have to people working at height. What's one of the biggest accident causes? Working at height. You know, so we're trying to use this as ways in which you can use this technology as well as on manned vessels as well as unmanned. By pushing it to unmanned, you look at the extreme, and then you bring it back towards what you can do for manned vessels as well. So, yeah. It's a great question. Yeah, you know. Marinisation of equipment that's exposed to the atmosphere and to the seas, it's always difficult. You know, things wear out, things erode, things rust, corrode, etc. You know, and you have to overcome that. And there will be a maintenance schedule. You know, so there will be work for people to come on board and remove corroded equipment and clean it.
Hi, Burcu Admanoğlu, and I'm a LLM shipping student at QMGL. I was actually wondering what happens if there's a pirate attack.
A pirate attack? Really good question. So one of the things about these types of vessels is there is no controls on board. So if a pirate jumps on board, then he's got nothing to control. But there is something called the sacred cow effect that I think is going to affect autonomous vehicles in towns and cities, which is human beings will soon learn that if you step out in front of an autonomous vehicle, the autonomous vehicle will do whatever it can to avoid you. So it won't be long before towns and cities people are just going to walk out to the roads and take over the towns and cities, and the cars will have to be deferent to them. So the sacred cow, you know, in India, you can go to India and if a cow walks on the road there, you give way to it, you know, so it's that effect. So there's nothing to stop a pirate from going, okay, what can I do here? I could actually just sail in front of the vessel and I could just shepherd. You know, so pirates will become shepherds. So the only way that you can overcome that is you can deploy some strategies. So one of them is that if you can maintain communications, you could remotely control it at that point, come back to the melee mode, and I could deliberately, you know, sort of ram the pirate's vessel if I wanted to. But a human will make that decision. Alternatively, you could make a strategy because, you know, you can see what happens. Someone will come along with some tin foil and put it over the antennas, and you'll have no communication. But you could then have some emergency strategies then for the vessel, which it will basically go towards safe waters. It will go direct, you know, on a dead reckoning route, as it were, with sirens running and lights flashing, such people around it are aware that this is a hijacked vessel and it's manoeuvring, stay out of its way. You know, so there are tactics which you could overcome. The basic one is pirates won't be able to control it because there'll be nothing to control. Then the question comes, yes, but they could get their laptop out and they could hack into it. So yeah, and that could be a threat for a manned vessel as well as an unmanned vessel. So we will learn strategies, and the pirates will then learn different strategies, and it will be, you know, the typical war of attrition that you get in any type of criminal activity. Good question, thank you.
In the Maritime Skills Alliance, how much in the skill set in the remote control centre?
All good.
The guy who was running the Spitzer tug used Master Mariner. I mean, it was the first test, of course that makes sense. But in your initial video, the engineer who was doing the technical analysis, what sort of skill set are you expecting him to? Were you assuming that he was a chief engineer or equivalent? Something clean to see?
Yeah, so I think this is a great question, and this is where we need your help. You know, because we need some guidance to what is the training requirements for people in remote operating centres. Do they need to be seagoing? So obviously the maintenance guys are going to be subject matter experts. Okay, so that's reasonably easy. But you know, but do you need a master mariner whose job is just to supervise? You know, is it more like an air traffic controller? Is it somebody that needs to have gone to sea, or do you need that person to then regularly go to sea, like once a year, like a pilot might do to keep his hours up? You know, And I think this is something where we have to come back to what's the risk what's the hazard we're trying to control, and therefore what are the strategies we need, and therefore what's the training requirement we need. I don't have the answer to that, and I'm actually looking for experts like yourself to actually come forward and to help the regulators understand what it will be. So great question. It is a bright area for analysis.
Can I chip in with one, because it's sort of fun. One of the most difficult things I think about considering what autonomous and remote controlled vessels will be like and how they will operate in the future is that we're often constrained by thinking in the context of the regulation and technologies that exist today. And 2030, I guarantee that your discrimination algorithms will be a lot easier because the vessels will be talking to each other and telling each other who they are and where they are and where they go and what to up to. I also think there will be fundamental changes. It won't just be a remote control centre covering a vessel from loading through departure through en route, through arrivals and offloading at the next one. There'll be a handover between controllers, and at times you'll have multiple control centres controlling different bits of the vessel, and then the difficulty will be who's actually in overall control, and these things are guaranteed to happen.
I was actually on the phone with Professor John McDermott from the University of York, who's being funded by the Lloyd Foundation, on that exact question. Is what research do we need to do to look at the human interface between the handover? Another area that we're beginning to get rumblings from certain authorities is that they would not want a foreign national controlling the vessel in their waters. So you could see a proliferation of control centres. So you could see the US government saying, well, we're not going to have anybody that's not a US national on US soil controlling our vessels in US waters. And they have the power to govern that, and I can see a number of other countries that will follow suit.
It was actually your comment about LNG vessels that made me think.
Sorry, the gentleman at the back.
Mark, sure, actually, you got the IMarEST given element working group, so I've got to be careful with anything else.
Well, Martin,
Couple of points. One is, I think we've got to be slightly careful with the safety argument and safety statistics. As you pointed out, not every ship in the world will be autonomous, and therefore the risk will not improve on every ship in the world. And to a great degree, many of the ships that are currently having the accidents are not going to be replaced by autonomous ships. If you see what my point is. Second point I would make is thank you for those pictures of the three tugboats that I ordered. I'm sorry that they're actually pictures of the past, but that I can live with them now. But as we already mentioned, tugs and towage are, they're not 21st century technology, they're 19th century technology. We're tying ropes on in the way that we've done for many years. An autonomous ship has got to interface with its surroundings. It's got to be able to berth alongside, and there are magnetic systems and vacuum systems and all the rest of that. Long-winded way of getting to my question. My question is there a dramatic difference between an autonomous ship that is what I would describe as pilot to pilot and one that's berth to berth? Because pilot to pilot says it's in the deep ocean by itself, and most of the risk is in the coastal waters. Once you're in the coastal waters, you've got to interface with the local port. So the question is, what is the incremental cost between port to port and berth to berth autonomous ships? Sorry for my definition.
No, that's fine. I mean, in theory, pilot to pilot would be easier to do. That interface is simpler. But as I said before, we're pioneering the technology in coastal waters, in ports around the coast. We're actually dealing with the difficult bit first. And as I say, the ferry example is one which is berth to berth. So that will be an automated operation, berth to berth. But it'll be an automated operation, so there will still be somebody that will be on the vessel that at any point in time can press the big red button and take full authority of that vessel, as it were. So the human on the loop, as it's called, as you know from your background and expertise. But that could be extensible to somebody in a remote operating area, because some governments are very interested in this technology about keeping communities connected during unsociable hours. They can't get enough people to actually crew or pay for those vessels in unsociable hours, but the communities want to stay connected. So actually, bringing people to sort of a remote centre and operating during sociable hours is a way in which you can connect communities together and do that. And again, that will be birth as it were. So yeah, and as I say, I think the international one is one which is a long way away.
Should have qualified it for the international.
Yeah, so I think that, but that's not to stop Denmark and Sweden interchanging goods pilot to pilot, because those two flag states could collaborate together and allow, with a common rule set, those vessels to operate between those two areas with no international waters being crossed.
A couple more from online, if that's okay. One or two pointed out about the depth perception on that video. I assume the answer is probably yes, but are you looking at considering virtual reality headsets?
Yeah, you could do that. Yeah, you could do that. And one of the challenges with virtual reality headsets is motion sickness. So there's got to be a lot of work done into with that in terms of how long can you operate with that. And but can you bring other technologies to bear that give you that depth perception? So with target acquisition, with data that tells you how far the target away very accurately, again, is that good enough? And remember, we're talking about a melee mode, which is actually not the mode we're expecting these vessels to be operating in. It will be a more tactical mode where you're actually saying, go to that point, bring that vessel alongside, etc., etc. So actually, the melee mode is in the longer term the infrequent mode of operation.
Yep. Okay. And someone else has asked, who are your main competitors in the market, and will Rolls-Royce? Do you think Rolls-Royce will be looking at whether you'll just provide the technology, or will you also be looking to provide the navigation services as well?
We're not an operator. We want to work with customers who because every single operator's got their own operating model. So they've got their own operating procedures, they've got their own business models. So they're the best people to advise. I can't generically provide that. So it's about working in collaboration. So our business model at the moment is about providing the technology enablers to do it. We do have master mariners and chief engineers that help us. It's about the interface between the human and the system and about the basic operation. But ultimately, those who actually operate vessels, they'll be in the position to understand how to program the technology and utilise, as it were, and everybody will be different. We have quite a number of competitors. There are other vendors out there available, and as I said before, we really welcome the fact that others are pioneering this technology as well, and I think that innovation will drive reliability, the safety, and the innovation to create the whole ecosystem. And we hope there'll be new entrants and new providers that come in there, because it needs refreshing.
Thank you.
Could I return to the bad weather conditions?
Oh yes, yes, we're still in the bad weather, are we?
The realities of life.
Yes.
It's all very benign in your videos and so on. At the moment, human manned ships are weather limited. They won't sail from ports, and beware coming into a port if the weather's particularly bad and so on. What's the state of the technology in terms of sensors and control systems, particularly if it's remote, to allow these new type of ships perhaps to sail in worse conditions than today's ships?
Yeah, so I have to say we haven't been looking at that as a particular technology thing. We've been looking at the conventional operation of those vessels. The scenario of bad weather comes into the use case, so I could be in the Bay of Biscay and it could be pretty nasty 50-foot waves around me, as it were. But how do I get into that condition? Can I avoid that? Can I use situational data that's available on weather and currents and the learning to not put me in those particular circumstances? So the other thing is about, can we operate vessels differently such that they can avoid those maelstroms and those sorts of conditions less, more statistically they won't go into them, as it were. But yeah, we're limited by propulsion. Propellers aerate. They lose thrust. Bad inclinations can cause equipment to fall hard and fail, and oil alarms to go off, etc. So again, it's about how can you make the technology around you more resilient to those conditions. And a lot of the electric technology nowadays is actually getting us closer towards things that can operate in quite harsh conditions. And a lot of our experience is working in the offshore industry in the North Sea, which is pretty bad. So a lot of our platform support vessels and anchor handlers operate in those conditions, and and we've learned most of the things quite the hard way, like sloshing in LNG tanks and other things like that. So we've learned over many years with manned vessels. Probably not a complete answer to the question, but.
Chris Campbell, consultant. A couple of questions, if I may. First one, you mentioned resilience, and I understand in the future equipment will be more robust. But at the moment we do have ships that have single engines, we have systems that do break down. I assume you're talking about in the future having more duplication systems in order to cater for that, where you don't have something on board you can repair when things go wrong. So that was the first question.
Yeah, so one of the great things about us reviewing the operations of ships with our customers is that we're actually going to the use cases. How do they really operate the vessels today? And what are the hazards that we are trying to overcome? And we're coming from this from prevention of hazards. So if you look at the way that the rules and regulations, they're all based upon the last accident, and we've built up this prescriptive set of class rules. We're coming at it from a risk-based approach, which is saying, right, how are we going to use the vessel? What are the hazards that we need to overcome, and what different ways can we do that to overcome that? Which could be through redundant systems. It could be getting rid of single points of failure. It may be where we have single points of failure, we just over-engineer and over-design such that failure is a remote possibility. You have to look at emergency and contingency. So one of the areas that we're looking at is what we call defence in depth. So we've gone away to our nuclear industry, because we do nuclear power for submarines and for power stations. And we've taken that defence in depth sort of set of principles and bringing that into our domain to say, right, how can we actually use defence in depth as a mechanism and a way of thinking to engineer better systems, as it were. So we're not limited by the prescription that's out there today. We're coming at this completely new.
John's been trying.
John Harrison. I was retired in 2002. That's 15 years ago. I think I'm amongst the elder brethren here. The only one I recognise is John behind me here. We've got some nice young ones here. One of the reasons the reception guest recognised me when I came in, which surprised me. Yes, I can't remember whether you used the word cynic or sceptic, but I'm both for sure, and a pessimist. But people who've had good experiences, I would say, probably don't remember them. But when you've been involved or around things that haven't been so good, you tend to remember them. I mean, going to the big ships, thinner ships, I was the early 70s, around about 2000 TEU, totally refrigerated, the biggest of its type at that time.
Yeah.
We're now talking 20,000-ish or something. Still one engine in many.
Yeah.
Weather, I don't know when, it's probably happening every decade. But I remember one year there was more than one ship, Hamburg, Sud, whatever, many containers. The diagonal latching is mostly held, but the ship was rolling very badly. Had to get into port with containers hanging over the side. How are you going to handle that? I mean, one thing that if you did it annoy me, you've used up to 6 times in a single long sentence. You know. We don't know. I tried for decades to avoid using that terminology as well as the double negative, because that's a total disaster in communication. In ship types, you sort of come there about tugs and offshore supply boats. Yes, they're carrying goods, but I had a sort of brother-in-law, late brother-in-law. He worked for IMarEST at one time. One of the two, he was one of the group of 9 that towed out that giant concrete platform. but a lot of time I use anchor handling. That is a hands-on job, because you're fishing for something, and you might get it or you might not. There's things like that, so they are different vessels. Your Norwegian fuel ferries, yes, they are a nightmare for many ships. I was on a sea trial on a 24-knot or something, again, big container ship, going up Hardanger Fjord, and they were coming alongside, toot, 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 and as soon as we were going a bit faster, they went under our stern. That's the way the ferries work. Are you going to let them do that? Can you stop them?
Absolutely.
Yeah.
In amongst that, there were a couple of questions. What was how are you going to handle the displaced cargo?
Yeah. So, yeah.
And the other one was the
road ferries.
Vessels doing what you don't expect them to do, which are common codes.
Yeah. So, no, I don't have an answer for displaced containers, and as I said before, I don't think the large container vessels will be right for this technology. There are some technologies there that we can help. So first of all, as you know, when you stack a lot of containers, the sort of the bridge visibility is really restricted, you know, sort of within sort of 500 yards of the bow. But with situational awareness, you can actually carve away the view of all those containers, and you'll get great situational awareness on the bow. So I think that's where the technology will help for large containers, and that's something that we're looking at the moment, as it were. So yeah, we could pre-program our ferries to go under the stern of container vessels that happen to be on the fjord. Or we could be a little bit more conservative around the navigation or sea keeping that would keep you a certain distance away whilst trying to maintain your timetable, because it's the pressure of timetable. But of course, when you've got human beings on board, sometimes some people will take greater risks than others. At least with an automated system, it will make the same decision and it will be consistent in its operation, unless that particular owner-operator begins to start shading some of the margins away and take risks. But it's only the same as...
When you're on a speed trial, you fly a flag, which is supposed to give you priority over everyone. Yeah. But these, we shouldn't very ignore it.
Yeah. Well, they might not in the future, John, because they can be programmed to do that.
Yes.
But those are the sorts of rules of the sea that have to be pre-programmed in, so the collision regulations, the trials at sea, do we do an identification of a flag, or does that vessel indicate on AIS that it's undergoing those, such that it can be recognised and we can deal with that.
No, I guess that's possibility are all there.
Yeah.
Well, we've got one gentleman in the back there. We've got you and one more.
Thank you. Good evening, Kevin. Rob Stevens. I'm Head of Customer Experience for Vodafone Global. I was intrigued by the video that you showed, the vision video, and the use of voice extensively as a user interface device, which seems to be replicating the way command systems work today on board ships. I'm wondering, is that actually part of your roadmap, or is that PR for you making it a bit more palatable for people in the industry?
Well, on the particular video, there was a concept that he was communicating with crew on board, so he was telling them what he was doing. But voice commands could be used to do control. So everybody has it in their car these days. Even though it doesn't work. I tried mine this morning; it didn't work. I said stop navigation, and it turned the audio off. But actually, where we're looking at it is more like, can we bring noise from the vessel to help the operator understand what's happening with the machinery? As I say, the master mariner, he wanted the noise of the engines, and he wanted to know that when he put the levers forward, he could hear the engine frothing up. That was something instinctive in him that he wanted to know. So we can deliver that. That's quite easy to do, and it enhances the operation, and it hopefully makes it more safer and more easier for that person to convert to use that. And there are other haptics as well. I've been talking to people at Daffey University in the Netherlands. They've got haptics that they're using on joystick controls. Which you could basically replicate, you could make things stiffer to provide a guidance to say perhaps you don't want to do that manoeuvre, a bit like what Airbus do on their aircraft, as it were. But again, that will come down to particular operators and how they feel safety is enhanced or not enhanced by bringing these features to bear or not. So yeah, everything's up for discussion and bringing into this technical revolution. But thank you.
And that would of course include 5G becoming available, which would be enhanced on.
Yeah. One of the hazards that we came across was when we went from phase 1 on that program to phase 2, and in the meantime, all our SIM cards they lapsed. The subscriptions lapsed, and so we got a new hazard now, which is the SIM cards lapse. What do you do under those circumstances when somebody hasn't paid the bill? So yeah. Sorry, that was a question.
Okay.
Daniel.
Online.
Yeah, one last one. Firstly, a couple of people have said thank you very much for the talk. So
Thank you.
Really interesting. And I'll do the final one, which is around ECDIS and chart licenses.
Yeah.
If you don't have bridges on ships anymore, will the licensing move to be based on one control centre or multiple ships that each control centre?
I've not thought about
I
it.
think I guess
Great
it's
question. Let's stop the technical revolution. We can't do ECDIS licensing. So
it's something that I guess discussions have to start.
Yeah, I guess we'll have a discussion with the
ECDIS.
Yeah, it's a really good question because there's a business model there that's been disruptive. Yeah. So what are the 24,000 vessels out there in the world today? And they've all got ECDIS on. Most of them have. So the business model could be disrupted. And sat navs, everybody's got it on the phone now, and the hardware disappeared. So these things happen very, very quickly. So yeah, it could happen.
Right. Thank you.
Okay, I think we've probably run out of time. I think we've definitely run out of time. So can we all give Kevin a big thanks?